All right, today we are going to crack one of math's biggest and maybe most misunderstood secret codes, algebra. I promise, it's not nearly as scary as it looks. Seriously, think of it more like we're learning a new language, and in just the next few minutes, we're going to get you speaking it. Let's do this.
You've definitely seen something like this before, right? You're cruising along with your numbers, everything makes sense, and then bam, letters show up. It's that moment where a lot of us think, wait, what just happened? But what if I told you it's not complicated? It's just a coded message.
Okay, take a look at this. Right now, it might just look like a random jumble of letters and numbers. This is our coded message for today. And I guarantee you, by the end of this explainer, you're not only going to know how to read this, but you'll understand exactly what it means.
So, just like any new language, you gotta start with the vocabulary. So first up, let's decode the basic words you need to know in algebra.
Let's start with the absolute heart of algebra, the variable. It's usually a letter, like X or Y, and all it is a placeholder. It's a stand-in for a number we just don't know yet. You can think of it as the main character, or the noun in our math sentence.
Then you've got the constant. Now this one's easy, because it's just a plain old number. It's constant. It doesn't change. So if you see an expression like 3x plus 4, that 4 on the end, that's our constant. It's predictable, it's reliable, it just is what it is.
Now, what about the number that's kind of glued to the front of a variable? That has a special name, the coefficient. Its job is to tell us how many of that variable we're dealing with. So in the term 5x, the coefficient is 5. It's kind of like an adjective, you know? It's describing our noun.
And finally, when you take all these little pieces, the variables with their coefficients, the constants, you get what we call terms. They are the individual words that we string together with plus or minus signs to build a complete algebraic phrase. Okay, so we've got the words, we know the vocabulary. Now it's time for the grammar, right? The rules for how you can put these words together correctly. So in this section, we're going to talk about a really important idea, combining like terms. Now, this is probably the single most important rule you need to know to get started. You can only combine things that are, well, alike. This means they have to have the exact same variable. It's the whole, you can add apples to apples, but you can't add apples to oranges thing. So 2x and 5x, sure, we can combine those. But 4x and 2y, nope, they have to stay separate. So how do we actually do it? Well, it's a super simple three-step process. First, you just hunt through the expression and find all the terms that are alike. Second, you just add or subtract their coefficients, the numbers out front. And third, and this is important, you just keep the variable part exactly as it is. Let's try one out together. Say we have 6a plus 2b plus 3a minus b. Okay, first step, find the like terms. We've got our a terms here, 6a and 3a. So what's 6 plus 3? That's 9, so we have 9a. Next, let's look at the b terms. We have a positive 2b and a minus b. Well, 2 minus 1 is just 1, so that leaves us with just b. Put it all together, and our simplified expression is 9a plus b. See? Not so bad. All right, we've learned how to read the code, and we've learned how to simplify it. Now for the payoff. This is where we translate our algebraic phrase back into one single number that we can actually use. This is called evaluating an expression. But first, a really quick but really important point. You'll hear the words expression and equation a lot. An expression is just a phrase. It has no equal sign. You simplify it. An equation is like a full sentence. It has an equal sign and you solve it. For today, we are all about expressions. Evaluating is also a super straightforward process. The first thing you do is substitute, which is just a fancy word for plugging in the number they give you for the variable. Then you just follow the good old order of operations. You might remember it as PEMDAS to figure out the final answer. Let's see it in action. So let's say we're asked, if x is equal to 2, what's the value of 3x plus 4? Okay, that first step is everything. We just take out the x and put in the number 2. So now our expression looks like this, 3 times 2 plus 4. And now we just do the math. Following the order of operations, we do multiplication first. 3 times 2 is 6. Then we add the 4, and we get 10. That's it. Our secret code 3x plus 4 actually just means 10, as long as x is 2. See, you're totally cracking the code. Okay, so we can read it, we can simplify it, and now we can even evaluate it. But you're probably asking the big question, why does any of this matter?
Well, let's talk about it, because this code isn't just for your math homework. It's literally everywhere. Think about shopping. Let's say one notebook costs $3. So, how much would it cost to buy a whole bunch of them? We don't know how many yet, right? So, we can just say the cost is 3x. Algebra gives us this really clean, simple way to describe that situation.
Or what about gaming? Maybe in your favorite game, you get 10 points for every level you beat, and you get a 20-point bonus just for starting the game. Well, your total score could be written as 10x plus 20. It's basically a formula for how to win, written in the language of algebra.
So, let's just do a quick recap of the code we've cracked. We learned that expressions are made up of key vocabulary, variables, constants, and coefficients. We learned the golden rule: you can only combine terms that are alike. We saw that simplifying just makes an expression shorter, while evaluating gives you its final number value. But I think the most important takeaway is that algebra isn't just a bunch of random math problems. It's a truly powerful language for describing the patterns and relationships all around us.
So there you have it. You've learned the basics. You can officially read the code. The only question left is, now that you have this new tool, what problems are you going to solve with it? Thanks for joining me for this explainer.